So, good morning, everyone. We have morning in Poland, so we can start. Thank you that you come into our webinar, preparing and making this gas global. I think that I will, let's say, some introduction to Gas Global Group.
My pleasure. My name is Bettina Heuter. I'm the marketing director to Glass Global for over 25 years, and I'm enthusiastic in the glass industry since my early years. It's a pleasure to welcome you to today's meeting and webinar on iMaximum. Before we turn to the technical focus of this session, I'd like to introduce Glass Global in short. We are not just an industry media platform. We are a business and intelligence platform for the international glass industry. With over 360,000 visitors per month and active since year 2000, we connect glass makers, suppliers, investors, project stakeholders with the information they need to make better commercial, technical and strategic decisions. A core strength of Glass Global is the combination of industry news, plant intelligence, market transparency, and project-related know-how. Through our international network, we provide visibility into developments across the global glass sector and help companies identify where opportunities are emerging, where investments are taking place, and where future demand may develop. One of the most valuable tools in context is Glass Global Plants. Through this feature, we provide information on production facilities worldwide, including locations, structures, capacities, furnaces, and expansions. For our clients, this means much more than just having a company database. It means understanding who is producing what, where, what scale, and with what investment perspective. The platform is designed to provide a global overview on producers, types, capacities, and so on. This matters because in the glass industry, decisions are rarely made on names alone. Real business value comes from understanding plant size, tonnage, asset structure, furnace age, and so on. Whether you are a supplier or an investor or an engineering company, looking at the competitive landscape, this level of market intelligence creates a clear advantage. We also do special studies and project-related analysis, bankable feasibility studies where reliable market assumptions, realistic capacity scenarios, and credible project documentation is essential. The studies highlight on the platform cover flat glass, container and tableware, include production capacities, import, export, and country-level demand perspectives. So when we speak about Glass Global, we speak on a platform that helps the industry move from fragmented information to decisions, stronger market understanding, and more solid project preparation. And this leads us directly to today's topic and the role of iMaximum. For glass manufacturers, energy is never just a utility issue. It's a production issue, a cost issue, and increasingly a strategic issue. Glass production depends on stable, continuous heat input. Any disruption in fuel supply can threaten furnace stability, production continuity, plant safety, and of course, profitability. At the same time, manufacturers, and who understands better than you, are under pressure to improve emissions, performance, strengthen reporting readiness, and maintain competitiveness in such volatile energy markets as we are now. This is exactly where iMaximum delivers real value. What makes the iMaximum approach especially relevant for glass makers is that it is not based on theory alone. It addresses very practical plant-level challenges. How can a manufacturer protect production against fuel supply disruptions? How can a plant improve flexibility without overcomplicating operations? How can emissions be reduced in a realistic way? And just as important, how can this be done cost effectively? In the solutions discussed today, such as LPG backup systems, on-site SNG, gas conditioning, and the integration of renewable gaseous fuels, are valuable because they combine operational security with economic logic. For a glass manufacturer, that means lower risk of costly interruptions, better control over combustion conditions, and more practical path toward future fuel strategies. Who could oppose against this? A particularly strong argument is the role of on-site SNG, or synthetic natural gas based on propane air systems. According in the webinar, SNG can be designed to match the combustion characteristics of natural gas. But I think that's Svetoslav to give you more details on that, because this is highly relevant for you because it supports smoother integration to existing burners, automation systems with far less disruption than other alternatives. It helps plants maintain continuity without forcing unnecessary technical complexity or major conversion cost. And there is also a clear cost benefit. Svetoslav will show that the investment can be 2 to 4 times lower than LNG backup solutions. And he will go into the major points. That means resilience and fuel flexibility can be achieved with a much more attractive business case. This is where iMaximum becomes especially compelling for the industry. The company is not offering only a technical backup concept, it is offering you a way to protect your furnace operations. And there is also additional value beyond direct savings. At the same time, these systems support more realistic route toward lower emissions. So you cannot move immediately to full electrification or hydrogen-based production, if that could be an alternative. iMaximum solutions are attractive because they allow you to take practical intermediate steps, including renewable full integration and staged fuel switching. That's why today's seminar is so relevant. It brings together exactly the kind of discussion the industry and you need: practical, economically sound, and closely aligned with the realities of glass production. And therefore, I'm pleased to have iMaximum with us today and to learn more about solutions that help you as glass manufacturers strengthen operational security, improve cost performance, and prepare the future in a way that is both robust and commercially sensible. So please, Svetoslav, take over, and thank you very much for listening.
Thank you, Bettina, for great start. Very appreciate. So let me introduce. I am a sales manager of iMaximum company, a blending expert. Today we will enjoy mixing opportunity. And now I will show my presentation about. I believe that you see my slide. No? Okay. Do you see my second slide? Yeah. Mrs. Bettina, do you see? Only for checking only. Is the presentation agenda. Okay. In this presentation, we will talk about the technical solution and the world of mixing that go with gas consumption to your plant very precisely. First, we will talk about our company, Maximum in Poland. The second, we already know the situation in the world is energy crisis, and we talk a little bit about why we can help to you in this moment. And third, we talking about the backup system like SNG, why it use, and another much systems that can help, like a Methane stabilization systems. This presentation not be only like a couple of story, it be like a practical. I will show you in by calculating how we solve problems, how we select the right blender, etc. The fourth step, we talking about heating value stabilization and enrichment systems that we done in Poland. And five, the CO2 reduction fuel blending system and how we use renewable fuel to integrate to make some effort of carbon footstep, yeah. And third, it's a little bit about our installation and recommendation. We are an engineering factory company that we produce a blender on site. It means that our blender built in our factory and delivered to your site depends of what you need. If you need a backup system, it's like the uh, similar Vapor index of SNG like propane air. It's very important because the stream of SNG is like you have in natural gas, so you can switch anytime in critical, to without any replacements of the burner. It's very important. And then we can also make you some enrichment for your natural gas or to your source. For example, we can enrich you to glass factories by LPG natural gas. Yeah, we have this some installation Poland that we enrich a low heating value of natural gas. We call it LW in Poland by propane to give more energy. So we are specialized to mixing the the gas in the LPG. We mix natural gas. We use renewable gas like a biomethane, etc. A little bit about us. We are the first manufacturer in Poland to make SNG solution, but not only SNG. We also manufacture methane stabilize blenders, enrichment blenders. My colleagues have a 20 years engineering experience, so we make more than 500 installation-based LPG vaporizers, and we make more than 10 installation of SNG, not even SNG blenders. In the end of this presentation, I will send you this presentation also to your email. And in the end of this presentation, it will be a room of questions. So if you have some question, we can discuss later. About our membership, we cooperate with Polish Gas Chamber for Commerce. We prepare for him some standard to mixing. I will tell you later. We are member and cooperate with POGP. It's like a Polish organization for LPG. And now we cooperate strong with Gas Global, as we very appreciate this collaboration. Also, I am an author of many of article about mixing, why this mixing system helps in the Świat Szkła. It's a Polish organization of glass platform. And biomassa, it's mean for biomethane, how we use biomethane with natural gas, what the effect, and etc. That our companies that trust us, it's Nestle, Humgas, BioVast is much more. What about glass factory? We make some installations, CG blenders for Valaria or LPG only to Uglas, etc. Company. Let it be about me. I'm expert of blending system. Also, I cooperate with the Chamber of Gas, Polish Gas Chamber. I am like team leader of 51 working groups. So we make some standards and norm for of mixing gases for industry. It's very interesting work. Also, we prepare some documentation and normalization about enrichment system of biomethane in our like to say biomethane for biomethane industry, because in Poland it starts very, I believe it's very rapidly. So let's go to our first topic. Sorry. What is our treatise of the stability of natural gas markets? As we know, the EU gas production is failing and import dependence is growing. It means, as you remember, 22, 24, there are some crises. I think now it's coming, yeah, because we have war in Iran. So it's tell us that Europe deliver import like 85% of LNG. So we need LNG, but we can help you to make some alternative system that we talk about later. And LNG supply has been disrupted. It means that in this conflict, like we have in effect to close the Strait of Hormuz, the 20% of global LNG export can close. It makes some risk now. And EU gas storage is dangerous low. It means that we have 29% of full of our storage. So everyone looking for stable LNG cargo. So it's very critically important for this time. And let's talk about some prices. As you know, the LNG prices, natural gas prices rose rapidly, more than 50% that we have before starting conflicts. As there's graph tell you the natural gas price and LPG price, because LPG we use for synthetic natural gas, LPG with air, and this is the backup systems that you can switch on your factory. So LPG is more stable in this 21, 23, but now the price of LPG going with natural gas price, but not so rapidly like a natural gas. Yeah. Also, here we have the cost of 1,000 kilowatts of thermal energy needs with consumption of SNG LPG. As you see, the price will be the similar of natural gas. It's from 1 April 24, but now they're very dynamic. I think natural gas will be higher than SNG system. And in the next slide, I will show you how we calculate it professionally, and I also can calculate for you. You can also tell me your prices, and I will send you some expert analysis of the system. Let's talk about something CO2 emission. As you see in this slide, the LPG is very close of natural gas, because LPG is like a pure gas. We talk about propane. Yeah, that propane, we call it propane in Poland. It means 95% of propane and 5% butane. If we have 40 to 40 or 40 to 60, it will be LPG, 50 to 50 also. So less than 95, we have LPG. And LPG do not have any NOx, so it's very good fuel to burn in the glass factories also. We put LPG some air to decrease like a Vauban index to make the same Vauban index like natural gas. I will tell you about later how to do it, how we calculate. And this slide you see that relevant CO2 compared to coal, propane give you 30%, and natural gas give you 40%. So even you put not green propane, only like a standard propane to your use, they save you 30% of CO2. Remember, compared to coal, you know. What a little bit about price that we pay in Europe for ETS carbon taxes. So our system can help you to reduce this price because we can mix renewable and renewable source like biomethane, BioSNG, etc. fuels to use to your mainstream of if you use natural gas, we can put something renewable to this mixture. Yeah, now we can speak about EU ETS, CBAM, and ASG. How the effect of this, like to say, sphere. So as you know, emission trading system must track and report the CO2 emissions, like a fuel use, fuel properties, emission factors, and verify CO2 output. Yeah. And what about CBAME? CBAME do not direct impact to glass, yeah, because it's cover only cement, aluminium, iron, etc. But our system can help you to be affected indirectly through customer supply chain, because even your customer use and produce some cements, your production with our system can help them to make some effort of CO2 food. So, and for example, for ESG, yeah, this means that energy and emissions data must be accurate and verified. So we produce systems that keep this very strong, very good way that you know how much you mix, which fuel you mix, how which fuels make, etc. So you see everything and you can control everything. Okay, and then how our system helps. So energy flow control blending system. You can set to our blender some kilowatts and megawatts of stream, for example, mixing stream. Then you tell him you need to use 40% of natural gas and 60% to some biomethane or some BioSNG, and they can do it. So it's, and also you manage this working, you manage what you use, what fuel you use, and how it impacts to your quality, for example. And CO2 reduction is the same way you can reduce by using fuels, not even in a stream like you using only gas stream. You can calculate with some solar. Yeah, you can calculate, for example, 10% I take from solar and 30% I will take with using some renewable gas, and also I can help you to calculate you efficiently. And renewable fuels integration system, it's like the same, so we can manage, we can use how much possible, for example, of biomethane if you have biomethane plane near, of you can use bioLPG and put the rest of natural gas. Yeah? Because as you know, in Poland, the biomethane is not enough for a glass factory because they produce only maximum that I heard. It's like 5 megawatts of biomethane, but we can use maximum of this and put another fuels to make some efficient. Yeah. Let's talk about our products. We are manufacturer of backup system, SCG blenders. We use vaporizers with, for example, Korea Gas Engineering Company. We make with our partners like Unical that here the summer represented in our webinar. We use boilers to make heating system. Yeah, we select the right LPG tanks. We select the right SNG tanks. We manufacture LPG pumps kit. Also, we make blenders to enrich system to stabilize heating value if your source is not so precise. Let's see. What's about our mixing and where the mixer used in glass factory more often because we know the glass factory do not have time. If something happens, the backup system need to run immediately. Power plants. Also, we talking about with our partners to make some backup to their backup because the power plants have very high need very high consumption of stream, but we can cover their backup. Metallurgic factory. We can help metallurgical to enrich their we call it a second gas for metallurgy. It's like we enrich not burning gas with propane, and then that can use second to their production. A candy factory as Nestle, some backup system. So our system work in Lviv because they are war very good. So they help to survive. Yeah. And we also cooperate with gas installation operator in Poland, like PSG or some gas system. We're talking about how we can help him to mix the right composition with gas, natural gas with nitrogen for gas system. And for example, for PSG, we help to enrich biomethane by propane because as we know, the energy of biomethane it's not enough to inject to give some to the natural gas line, and also biomethane plant we can help. When do we use advanced industrial gas blending? So now we speak only about an enrichment system, a gas backup system, CO2 reduction, decarbonization. And we built the backup system when NG pipeline infrastructure is very uneconomical and impossible. So we have such installation that we built very natural gas pipeline is very far yeah, of the factory, for example. Okay, let's go practically. Now it's our systems that we can talk. Like I can describe you. The firstly is a little bit agenda gas backup system. Firstly, we speak about then methane number stabilization system. Like we stabilize methane number if you use some syngas, pyrrolic gas, etc. gases by putting here some CNG, natural gas or biomethane. If you have biogas, yes, also, but it need be upgrading a little bit. And So the first is we'll be talking about the heating value stabilization or enrichment system. Please stay to the end. It will be very good knowledge how to calculate. Firstly, let's talk about backup system, SNG system, synthetic natural gas. It's a propane or LPG-air system. It's very important that we make the SNG with the same Vobbe index like we have in natural gas. It's very important for burner. If you make the mixture with some Vobbe, you do not need any configuration of burners that configure to natural gas. So you can switch immediately and that can work with your burners. We call it this backup system. How it look like? So you have LPG tank, you need pump, some vaporizers, SNG blender, and you can use air. Why you use air? Because air is inert gas, and LPG have a high Vobbe index. So we decrease by air the Vobbe index of LPG to make the same Vobbe index of natural gas. And for second little blender, you can mix natural gas with SNG with any proportions that you need. For example, you calculate the SNG stream will be cheaper than natural gas. With our system, you can mix, for example, 80% of SNG and 20% of natural gas if you decide the SNG stream will be cheaper. Yeah, but remember, the SNG is do not have the same methane number because methane number of SNG is 21 and natural gas is 80. For this, you can use SNG to the cogeneration system. It's very important. But if you need to stabilize methane number, I will tell you later how to do it. Can we help with this? Now there is my calculation that I calculate how much you need SNG to go with reference gas source. It means that we make, for example, in the left you have 25 megawatts by natural gas. This calculator tell you that you need 1000 is the right 1400 normal cubic meter of SNG to get the same flow rates, the same 25 megawatts. Now, after that slide or second, I will show you in real time how we calculate it. And this you see that you to keep this Vobbe index 53.11 by natural gas, you need the same Vobbe index of SNG in the right 53.12. For do that, you need to put in the LPG 39% of air, and then you will have the same Vobbe index natural gas. The heating value will be different. As you see, in heating value of SNG will be like 61 and natural gas will be 41. Why it's happened? Because remember, in the SNG you have air inert. To make this mixture efficient, you need to put the more propane to stabilize Vobbe index. Also, I can calculate for you data anytime. Please send me your data. Also, we also keep your data in this calculation. So if you have in your era LPG of composition 50 to 50, we can also go with this composition. And this calculator tell you that you need only 1.27 meter cubic per minute in 7 bar flow IL stream. So you can also know, you can also understand how much air need and how and the volume air how impact your production, because we understand the air have some oxygen, nitrogen, and that also can impact. But we can help you to control it because we make installation of this. And also you have here, if you blend in 1 bar, the LPG dew point will be -70. If we use propane 95 butane, so our mixtures it have a good condition, so that can work very well. Also, the second calculation that we have, we can calculate you the efficiency of mixing system. For example, this calculation make for some customers. I give from him data how they pay for liter of LPG and how they pay for kilowatt of natural gas. And you see, if we mix 75 of SNG and 25 of natural gas, the factory save $44.62 per hour, $1,000 per day. So in the graph, right, you see how much they save if they put SNG from 0 to 100. So if they use 100 SNG, they will save, they will save 1,000 $1,700 dollar per hour. Yeah, okay. Now we will go to real calculation. We like some practice. Let me find my calculator. Now, let's go. Let me share the calculation here. Okay. Yeah, let's imagine that you send me some data. Okay. For example, you know that energy heating value of natural gas in your area will be 38.5, for example. In SM cube, standard meter cubic, in 50 degrees, my calculator calculating it's normal. It means zero Celsius and 1 atmosphere. So they automatically calculate that the natural gas stream have heating value 40.60. So also we put here as a density to calculate the Vauban index of natural gas and how much you need natural gas to keep some flow in kilowatts, yeah, to keep some energy. So here we put the, for example, you use 24,000 kilowatts in your factory. So they automatically calculate you the Vauban index of natural gas, and in the middle we can select the LPG composition. For example, some in the Asia, you know, we have 50 to 50, and that automatically calculates you the Vauban index. Also, we can help you with tanks. So we calculate how much volume of tanks you need to keep operation time. Yeah, if you use, for example, 3 pieces of 100,000 liters, it's only size liters, but remember you need to calculate the real capacity. It's 85% of maximum. This will be 255. And that system, that LPG tons, and if they're used, it will take you workingly 3.44 days between refillings, yeah. And then you will see in the right the same Wobbe index SNG, and calculator tell you that you need 54% of LPG and 45% of air. In the middle you will find how much LPG you need in kilogram and how much air you need to keep this Wobbe index of SNG. In the normal, yeah, it means normal cubic meter per minute. But if you use some compressor, for example, 7.5 bar, yeah, and you can select the right compressor that you need 1.3 cubic meter per minute in 7.5 bar. Also, we recommend some reserve because something can happen. We recommend 10% of reserve in LPG and 10% of air. If we put here some 20%, yeah, and 90%, the SNG capacity with operation reserve 25 would be 1000. But this is tell you how much you have normal cubic meter. But for this, it's not so important. Very important. You understand that you have the same Wobbe index as natural gas. It's very important for backup systems. Also, in below, I can use your data, how much LPG pressure you have from tank and how much pressure you have from air, and I calculate for you DN is pipeline size, yeah. And then after regulator, because we need to regulate pressure to mixing pressure, for example, in 1 bar you will have a 40 degrees, high temperature like be in 5. If you select the velocity of 70 meter per second, that tells you that you need in inlet of LPG DN 150, IR 125, and SNG output will be DN 200. But if you only looking for some systems that can mix SNG with natural gas, with some reason, I will also can show you how much you need DN in natural gas to make be efficient. You know, and below you can also tell me some price, for example, for in LPG 1.4 USD per dollar, yeah, and I don't know 0.09, yeah, here. And we understand that some factory can use natural gas for cogeneration system, and never happens that you use 100% of SNG. But if you do not use cogeneration system, you can go with 100% of SNG. So here you have efficiently of this mixture. So this will be price of SNG, and there's in the blue the price of natural gas maximum. It's 2000 and there's 1200. But if we put here, for example, you decide that you use 70%, the they automatically show you how much you will pay for this mixture, 70% of SNG and 30% of natural gas. Okay. So let's go to another Blender solution in our presentation. Okay. Let's go. Yeah, we just speak about this. Let's show you some example. This is examples that we built in Ukraine during the war. We built it in 3 weeks because it's very big critical of a glass factory. You know, there is working working picture, but we can run it very quickly. In the left, you have a vaporizer, very good vaporizer. In the middle, blender. In the right, you have SNG buffer tanks. LPG tanks we have underground. And in the back, you have air buffer tanks. And they switch between natural gas. If natural gas coming, they switch to natural gas because in Ukraine the LPG price is so high. But they help him to make a production all time. You know, it's very important to glass factory. There are some blenders, our blenders that we make. Another photo is a backup system. The second, let's say, possibility is the stabilized methane number. We can also make some blenders that can stabilize syngas or by natural gas, by biomethane for some uses. Because I know some factories that can use a cheaper syngas, but that syngas is not stable, as we know. How it look like? So we have, for example, pyrolytic gas reactor that makes some syngas for us. We take biomethane or natural gas from pipeline, stabilize by a methane number for cogeneration, because for cogeneration is very important methane number. And then blender automatically evens the composition of pyrolytic gas change. So if we have one list of like say ingredient, they put natural gas more or less for this situation, and the customer can use for cogeneration system without any configuration. But if they are very critical, they put much more natural gas, and the customer decide if they use pyrolytic gas or they upgrade it by some technology to make better, because they have the sensors that can use even 70%, for example. But if pyrolytic gas is stable and cogeneration will be built for this pyrolytic gas, yes, but unstable in 5%, we can cover these not stable parameters by using natural gas, for example. As we know, the pyrolytic gas and have for one is the same customer as see. The same customer produce the two different pyrolytic gas. It's happened because the method is not so not like good, but not so efficient in some substrate. You know, because substrate of pyrolysis can be different, and we know the methane number of this ingredient of gases, will be 35 of methane number, and the second will be 47. So we can stable, for example, by using natural gas for syngas, we can stable to 40 to put some natural gas to the syngas or to the pyrolysis gas. Okay, the third solution is the heating value stabilization enrichment system. If you use natural gas, but stream of natural gas, it's not enough for you. Yeah, you need to make more heating value. We can put the LPG, or we can put the bioLPG, for example. So we enrich a heating value of natural gas using LPG. The same schema, so you have LPG tanks, pumps, some vaporizers, blender, and from pipelines we use natural gas. It's your main fuel, and we enrich by LPG. It is the same way. Also, we calculate how much you need propane or LPG to enrich your main source. For example, you use 3000 normal cubic meter by your low energy source like natural gas, but not so good quality. And you need to enrich it to 42 megajoules per normal cubic meter. And this calculation tells you that you need to use 9.48% of LPG mixed with natural gas to enrich to 42. And Wobe index will be like here, 50.5. Okay, let's go to some practice because I think it's important to understand better how it's calculated. Yeah, so there's the same way. So we put here the main gas. So it will be like natural gas. Let's go with better. But I have in Polish. Now I switch to English. I need to use, for example, some natural gas with good quality, 41. And you know that you use 3000 normal cubic meter to your production by this natural gas good quality. Yeah. Okay, that we calculate Volbe index here. So you put here the data. We know all data about natural gas, and we need to know how much you need LPG. For this reason, you put here the heating value of LPG of propane. We already know the heating value of propane butane composition. You can also tell me some composition and I can calculate the heating value because it's very easy. And then we select the pressure. We mix in one bar here because you can take from your pipe, inlet pipe, natural gas 1 bar, and we mix the same pressure. The second gas will be a little bit higher, for example 0.5 bar. Second gas is propane. So the calculator tell you how much we need propane to enrich in 1 megajoules. So for example, to enrich to 42, remember that we have 41 here. Yeah. we enrich to 42 and calculate tell you that you need 1.68% of propane to mix to natural gas line. But if you press here 45, oh, sorry, it's not here. I need to press in English, Polish version because it's built like this, 45. Yeah, 45, and that tell you that you need 6.7% of LPG or propane of this heating value to enrich it 45 megajoules. So in the end, you will have a stream of 3,300 meter cube, and Woba index will be 55.06. Also, I can calculate for you everything. You put me some, you send me some, you send you some data of your source, and I calculate for you energy of this source and how much we need LPG or another gas to stable by heating value your source. And also, I do not translate it, but in Polish we have that I also can calculate how much you pay for second source, for example. How much you pay for 6.72% of LPG, and how much you pay in by hour, by day. And if you use cheaper, I can also calculate you how much you will pay the main source. Yeah. Okay. Let's go to the presentation. Okay. I will be switching between presentation to calculator to make some practical steps of this. Let's talk about some renewable fuels. BioSNG. What is BioSNG? It's a bioLPG with bioLPG with air. Yeah, not with natural gas. Sorry, it's a mistake. bioLPG with air. It will be like that. We have the same. Sorry. Let's air. It will be same like natural gas. Why it's important? Because we can control the renewable fuels in a BioSNG, and we can calculate how much we can use BioSNG with natural gas to go with CO2 efficiency. Why we can use only bioLPG? Because if we use bioLPG directly without air, that effect you that we enrich natural gas by bioLPG. But we need to make the same fuel that have the same Woba index, but with renewable fuels. The Woba index need to be the same as natural gas. And this reason we use BioSNG. What is BioSNG? bioLPG, it's make from some vegetables, glycerol, etc. So from some biomass sources. It's green, but some countries do not have this fuel that can use biomethane also, no problem. But bioLPG is some opportunity, some good renewable fuel, stable one, because bioLPG has the same quality how, like to say, composition like LPG. They have same heating value, so you can use bioLPG with LPG. And this in this renewable decarbonization, we can use system that can mix SNG with natural gas to keep kilowatts. Yeah. And also we can calculate how much you need biomethane to natural gas stream to make some CO2 efficient in your company. Also, I will show you how we calculate the BioSNG impact to natural gas and how it's, let's say, make some decarbonization in your company. So the fourth, like the first of this solution, we make blender that can use natural gas if you have some limit. For example, we work in some project in Bangladesh. The Bangladesh have natural gas limited in some region. We can prepare synthetic natural gas for him and mix synthetic natural gas to natural gas to use in case to use maximum efficient of natural gas, because SNG, the cost of SNG like be higher of natural gas, and our blender use SNG maximum efficient to keep kilowatts. Yeah. For this, you need use a little blender. It's the same schema that we have previously. That's the schemas that tell you that we need LPG, pump, vaporizers, air compressor to make a SNG blend, SNG mixer. And if we use a smart peak shaving system, it means if peak shaving system tell us that natural gas with natural gas going some trouble, for example, pressure go down, we add more SNG to stable natural gas. But is this also happen if natural gas damage, for example, pipeline, something happen, or in our area, there will be some problems. We can cut off natural gas inlet and switch to 100% of SNG. But this system, little blender work automatically. That only they know that pressure go down to minimum, and they switch between natural gas of SNG, or you select mixing 30% of natural gas and 70% of SNG that will be mixed automatically. But if natural gas drop, they switch automatically to SNG to keep the kilowatts you need. It's very important. Yeah, it's the same calculator, but remember that we put the heating value of mixture, but in this we put not heating value, but it's not important for us. We put mixture energy output. For example, 25% of mixture you need in your production, but you know that you can use only 1,000 normal cubic meter of natural gas, and 1,000 normal cubic meter of natural gas, it will be like 11 megawatts. But you need to know how much I need to put here SNG to make 25. No problem. We select the blender that can automatically mix one source of natural gas maximum capacity with SNG, and then generate automatically on your site yeah, because in your site you have LPG tanks, so that make you independently in the very critical moments. And you see here that you use 1,000 normal cubic meter by natural gas, and you put 797 of SNG to keep this 25 megawatts. And also you will know what is Wobe index of this total mixture. Let's talk about some reduction, because it's very smart our system, how it's work. So to reduce some CO2 of natural gas, remember, by using BioSNG, and you can use BioSNG with SNG also to reduce CO2. Why is it important? Because if you do not have any natural gas source, yeah, it's happened. You can use only base it in bioLPG and LPG solution. How it look like? You also have some tons of LPG, pumps, vaporizer, blender, and blender make for us some SNG mixing. But we calculate for you, and we will teach, we will show you how much you need biomethane to reduce the CO2 of your factory. So it's the same way that we blend biomethane with SNG with right proportional to reduce CO2, comparison to natural gas or to coal, maybe for natural gas in the glass factory. Also, the second way that we use biopropane, the biopropane tank, we have pumps, so we have bioLPG, vaporizer, bioLPG with air make us BioSNG, renewable fuel, and we can mix natural gas with BioSNG also to reduce CO2. How to do it, I will show you by calculation. But the third possibility is if you use only LPG and bioLPG. So you need two different tanks, or 4 tanks by 2 different sources. For example, you have 1 tank of bioLPG and 1 tank of LPG. You mix LPG with air periodically. For example, you mix 1 hour with LPG air, you switch to second tank and mix bioLPG with air with some blender, because remember the LPG and bioLPG have the same Wobe index, but if they not have the same, our blender automatically configure to write Wobe index in the end. Why it's happened? Because you have the same vaporizer station that also can be very dynamic, and you do not need 2 blender. You can use 1 blender, and in the end you will have per day the sum, let's say, consumption, yeah, that you know that you blend in one day 40% of BioSNG and 60% of SNG, and they can make some efficient of your factory. There's also some way we are in the process to make this installation in some countries, but now I think some NDAs that I can tell you, but this real can work with any problems. As you remember our calculator, theirs will be the same that we put here as a natural gas main source, and we put here the bioLPG mixture. For example, yeah, we have 95 and of propane, biopropane, and 5 of butane, biobutane, let's say. Yeah. And they tell you how much they need to reach, how much they need biopropane to reach 25 megawatts. But we understand that the bioprotein of this value is not possible because it takes a lot of money. Yeah. So we decide to mix a part of BioSNG, like it's BioSNG with natural gas. How we calculate how much you need to mix BioSNG with natural gas? Because we have also the smart calculator that you can tell him that you can press some data. I need 30% of CO2 emission reduction by a comparison to natural gas. Yeah, so 30% my end mixture be better of CO2. How we calculate it? Because we know the BioSNG emission in Polish country we have the COBIZE. It means official documentation that tell me that bioLPG have 9.2 kilogram per CO2 in gigajoule. Maybe in your country will be different. Also, we know how much emission we have from natural gas and how much, emission we have from LPG. But you see, the emission of bioLPG is much lower, and it will be very possibility to use this in our mixture. On this data, because in Polish bioLPG have some POS. POS is a legal documentation that mixture can keep this value. And you tell us that you need to reduce 30% of CO2 in your natural gas stream. Yeah, we can put here the SNG, BioSNG. Previously, we mixed bioLPG with air, and you need to use 34.3% of BioSNG and 65% of natural gas. Our blender will be mixed it automatically, and you know strictly that you will reduce 30%. But imagine that you do not have bioLPG. Yeah? You can use biomethane, because also biomethane have a legal documentation how much emissions that have. You can put here the biomethane value, and also we can reduce CO2 by mixing biomethane. And there's a CO2 emission reduction if you use 100 of BioSNG in your mix. And if you use some percent of BioSNG in natural gas stream, for example, it starts efficiently from 10% here. You reduce 7.5 CO2. And if you put more, mix more, then we have better CO2 emission reduction. But if we compare thing to another fuel, we can also calculate for you not comparison to natural gas, for example, to some coal. I don't know, maybe use coal for some reason, or another gas. We can also calculate you how much you need BioSNG or biomethane. There are some photos of our factory. In this photo, you see that we in front have a blender that we already make for some biomethane plant in Poland. We enrich biomethane by propane. Yeah. So also the blender have a the CE certification. So we make a PAD test for that. Also in the back you will see our blender, syngas blender or methane stabilized blender, also with very precise working. If you if the stream of, like example for LPG change, because we have the situation, if we sync some contract with our customer and customer tell us that they use propane, but in some reason they use LPG, not propane, with high heating value, our blender automatically change ratio of air, and in the end they have the same bobot, even they change a source. Also, it's happened with biomethane, because biomethane also have some like evaluation is some value, difference value. For example, they all in one time they have 38 megajoules, and the second they will have 37. But also in the Polish, if they need to use to the gas grid, the minimum need to be 38. But if you use in your own solution, the biomethane can be worse, yeah. And LPG or bioLPG can stabilize heating value. And you have you reach to source, you reach to efficiency. For example, you reach the renewable fuels in your mix, and you reach a right heating value of your production line. Little bit about our blender. For example, for SNG blender, we start mixing with 205 meta cube per hour to 8,000, depend of your needs. They do not need any container. We calculate and we produce it for staying in the weather conditions. So we call it a skid. They need only some shelter roof, and it will be enough. But if your condition is not so good, for example, you have a lot of dust, etc., we can build it in the container, no problem. So about our services, we do not only producing, we are expert of calculation, we expert of design. We can design for your system, depend of your goals. We have the installation, we make more installation. We have a lot of experience to select right equipment, because this system, it's not even blender. You need right vaporizer, you need right tanks. You need to be sure if you're going with us, you will be sure that it's work like 15 years without, if you have some with us much problem. Also, we can do some documentation for you if you need, and we can supply for you some LPG or SNG equipment. Also, we can recommend for you some factories that you can buy own. If you're from not Poland or another countries, we can select for you right LPG tanks or SNG equipments, and we're ready to help by our service team. You can call us. We can go to your site, no problem. About our working installation in the Lviv, we have installation SNG blender. It's Nestle in Valaria in Ukraine. We help to build SNG blender for him, and Uglas also in Zhytomyr, Ukraine. In the Polish, we in the stage of build enrichment blender that we enrich biomethane by propane. I think it will be built in summer this year. Also, you can use only vaporizer, so you can use only LPG for your reason, for example. Not you do not need any blending, because we can change your burners to LPG if you decide, no problem. But if you know that you need to use natural gas because it's critical for you, you need blender that makes the same Bove index. Okay. Also, for example, this will be very good project. For example, for 20 LPG storage tanks, each they have the 100 meter cubic. It for CHP plant in Ukraine because there are war. And we in discussion how to make SNG fuel to the some couple of buildings like living sphere. I think it's like in Pakistan also we have some request. It is interesting because it will be some good source of stream of gas. Many thanks that you stay to the end. You have here the contact to me. I will help you to calculate, to make a right blender to your needs. Now I will open floor to questions. Let me allow you. It takes some time. So if you have some question, please ask.
It was a very, very good explanation. Thank you. It was a pleasure to have you with us. The approach that you gave goes exactly to the needs of the glass makers, production, lower risk, flexibility, smarter structure, and it also addresses the fillers who can justify these investments in glass factories when it considers reduction of CO2 and the carbon footprint. Thank you again for the valuable insights and demonstrating how the solutions can deliver a practical value for the industry. I look forward to have the next run of the webinar to go deeper into the insight and to raise questions by the users. And to all of the participants, thank you, and we invite you to stay connected through Glass Global Network, through Svetoslav's email address, and to get more industry news, updates on iMaximum developments and a prosperous future.
Thank you so much. So stay in touch. Thank you. Bye.